And later on we will have a look at the Schrodinger equation, where this Schrodinger equation is important or vital equation in quantum mechanics, where it is the foundation of quantum mechanics by using this Schrodinger equation. If we are able to solve this Schrodinger equation, we can solve we can know everything about any system. So for the Schrodinger equation is a content of Hamiltonian function times with wave function equal to energy or eigenvalue of the system and a wave function. So it is derived from the Newton law. So it still have a classical mechanic factors in the equation. So I will not ask, or I will not jump to all the derivation. However, what I would like to state here, this equation here, this equation, this Schrodinger equation is become a foundation of a modern quantum mechanics. So for Schrodinger equation, he won the Nobel Prize in Physics in 1923 for the discovery of new productive form of atomic theory. So that's why we can say that's why his theory become a foundation for the quantum mechanics theory. And later on, a few or several mathematicians are using his theory to derive another derivation for the quantum theory. So for quantum mechanics theory, we have a lot of equation. However, all the equation is based on the Schrodinger equation. So for the quantum mechanics, we are talking about the probability to find electron in a system. For example, we have this kind of graph. So this means that if you still remember, like if we have hydrogen, if we can draw, so here is the electron. Here is the basis where we try to put the electron to the respective shell. However, in quantum theory, we are trying to predict where to find the electron. So here is a few examples of the calculation of electrons. So we do have this probability distance from the nucleus, and also we have a probability. Here is the probability of to find the electron, and we have a certain mathematical work here. Mathematical work here, and then what happened here is from there we can predict where is the electron at a certain time at a given time. So that's why we do have this kind of form, or this kind of a graph. So here the graph shows the probability of to find electron at a certain time. And if we look, if you still remember, we have N, we have L, M, and S as its speed plus or minus 1. So if you still remember, we already learned this one in our matriculation level. So all of this number is derived from a quantum mechanics theory. So that's why we get all of the number. And then if we go further, here is the interaction between the two system, two electron. So when we have this one, we can predict how the electronic configuration of a system. So electron, what is the crisis in physics that demand QM or quantum mechanics? So here it is because of we can say to that when we have a hot object, it will emit more ultraviolet light than they do because of in physics, or when we talk about light are able to give energy to us, to produce energy by using this equation, E equal to hv. And the factor that influence the energy is the V. V is the frequency of the light. So that's why at a certain light level, we do have a certain kind of energy. It depends on the frequency. So the longer the frequency, the less energy that it have. While the short or the frequency, where the frequency have a short distance, you have a high energy. It's going to be a high energy. So Max Planck solved this problem. Max Planck postulated the light quanta. So that's why if we have a few set of light, every light or that have depending on the frequency, it will have a variation of energy, because Max Planck give the theory of a quanta. What is quanta? Quanta is, let's say, if we do have light, let's say if we have light, this one we call is every part is one we call photon, and it have a certain, or we can add energy. It have its absolute energy, or it have certain value of energy, and this energy can be determined by using this formula, E equal to hv, where h is a Planck constant and v is the frequency of light. So to have a better understanding about this, light is quantized into packet of photon. For example, if I draw it like this kind of light. So this one, each of this one we call it as photon, and this photon carry the energy. And to determine the energy, we will use this formula, E equal to h v, where h is the Planck constant, here is the Planck constant, and v is the frequency of the light. And then we know that the light, we can have a variation of light. We can have electromagnetic. So each light have its own energy, because they have a variation of the frequency. So there is a question here. Why has red light incapable of knocking electron out of certain material, no matter how bright it is? It is because of the photoelectric effect. So this is the energy of photon. So I can say here, if we compare this light, so here we have a longer, and here we have shorter. So this carry more energy. So this is a photon. So Einstein, and this one is called photon, and so photoelectric effect is mean that any certain particle, it can only absorb a certain amount of energy. That's why if we give a more energy, so this electron that contain it in the system can absorb the light and emit. So this is we call it as energy of photon. So this is a theory that is given or produced or deduced by the Einstein. I think the bright mind in our century. He devised this theory, and this theory is coming from the Planck theory. He just improvised this Planck theory. So and he won the Nobel laureate when he proposed this theory, because this theory is become a game changer in physics. So by using this quantum theory, we know later on we know how the electrons look like, the behavior of electron, the energy of each electron in a system. So for example, here is the electronic configuration of electron, where we know how the electrons are being arranged in a system by using SPDF. By using SPDF theory. So I believe that you had learned it before. So try to have a look at the metric book and try to understand how this all of these electrons are being arranged in the system. And for example, here I can give you the example. Here is iron. We have a 26 electron. So if we remember, we learned it before in secondary level. So for 26, we can arrange it like 2 egg